Welcome to the Biochemistry Clinic. Today we look at yet another exciting route for glucose 6-phosphate. Remember glycolysis, pentose phosphate pathway. And now we are looking at uronic acid pathway, which is simply another alternative route for the oxidation of glucose. And it also starts with glucose 6-phosphate, which is converted to glucose 1-phosphate, and then UDP glucose, and then to UDP glucuronic acid. Now here I want us to pause. UDP glucuronic acid is actually an active form of glucuronic acid. Now why is this important? Now this is important because it conjugates with bilirubin, steroids, and drugs. What is the importance of the conjugation? Now the conjugation here simply enhances or increases solubility as well as makes it easy for excretion. Another important thing that we need to know about UDP glucuronic acid is that it is involved in the synthesis of glycosaminoglycans or GAGs. Now, apart from its function in conjugation with bilirubin, steroids, and drugs, UDP glucuronic acid can be converted to glucuronic acid itself or glucuronate, which can be converted to golonate or golonic acid. Now, here we have to pause again. There are two routes that this can take. Now, the two routes are actually in different environments. So in lower animals, golonate can be converted to ascorbic acid. So through a series of steps here, golonate can be converted to L-golonolactone, which is later converted to ascorbic acid with the help of the enzyme L-golonolactone oxidase. Now, this enzyme does not exist in human beings, for instance, so you do not have the ability to produce ascorbic acid. This is a preserve of lower animals, and that's why we advise you to simply have diet that includes ascorbic acid or vitamin C, because you do not have this enzyme that can convert golonate to ascorbic acid. Now, what is your own portion? Your own portion is here on the right side. So golonate in human beings, like you and me, can be converted to 3-keto-L-golonate, and then to L-xylulose, and finally, L-xylulose is converted to its D form, which is D-xylulose. Now, again, when you get to this point, something should ring a bell. D-xylulose is one of the products in the non-oxidative phase of the pentose phosphate pathway. So D-xylulose can actually enter the pentose phosphate pathway. And of course, if you want to be a little bit more ambitious, you can actually continue with the non-oxidative phase of pentose phosphate pathway, where D-xylulose can be converted to intermediates of glycolysis like glyceraldehyde 3-phosphate and fructose 6-phosphate. So there's actually an interesting interplay between uronic acid pathway, the pentose phosphate pathway, and glycolysis. Now, this route that leads to the conversion of xylulose, L-xylulose to D-xylulose, has some interesting medical aspects. Why? Because a deficiency in the enzyme xylator dehydrogenase, which is used to convert L-xylulose to xylator, would lead to accumulation of L-xylulose. And once this accumulates, you are likely to have a condition known as essential pentosuria, where you have xylulose appearing in your urine. So this pentose sugar is in your urine. And this actually can be seen from a positive Bendix test. Remember the test for reducing sugar? So when you have an excess of xylulose, L-xylulose, you're going to see that it appears in your urine, actually leading to a condition known as essential pentosuria. So this is as a result of a deficiency of the NDPH dependent enzyme xylator dehydrogenase. Now, what else are you supposed to know about the uronic acid pathway? Well, there are actually a few drugs that I've indicated here that have an effect on the uronic acid pathway, and this is barbital and chlorobutanol. Now, these have a very interesting effect in that they actually activate the pathway in